The Pythagorean Theorem. This is one of my favorite subjects and one of the most practical subjects that we teach throughout this year. So let's get started. So if you notice, I've got a picture of a right triangle on the screen. And what it's depicting is that there's a relationship between the three sides of a right triangle. And we're going to show you what that relationship is in this section. So first of all, in our guided notes, let's fill in these words. In a right triangle, the two sides adjacent to the right angle, so that's these two sides up here, how they tie into that right angle right there. Those two sides are known as legs, or A and B. And when the triangle is situated like this, I usually call the one going up and down A, and the one going across the bottom B, but it doesn't matter. You can just say A or B, and they're kind of interchangeable. The side opposite from the right angle is called the hypotenuse. That's called the hypotenuse over there. And you can always tell because it's straight across from the right angle. And it's also the longest of the three sides in every right triangle. Okay, so let's label these A, B, and C. So we know that the two legs are A, B, and the one across from the right angle, C. Well, let's go to the one straight across from the right angle. Let's just go with C first. That's the longest one. Then A, B. All right, here's the one across from the right angle, C. And then we can just go A and B. Well, then here's C, A, B. And that's all you need to do on this slide. This little section right here is not needed. Okay, now what is the Pythagorean theorem specifically? The Pythagorean theorem tells us how the side lengths of right triangles are related. In any right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. This relationship can be represented by this equation. So we've got A squared plus B squared equals C squared. Now when we talk about A, we mean however long side A is squared plus however long B is squared will always equal however long C is squared every time you have a right triangle. There's no exceptions to this rule. So it's kind of depicted right here. If you look at these three squares, this square has the dimensions of side A. This square has the dimensions of side B right here. And this square has the dimensions of side C. Same length as the side of the triangle there. But if you add these two squares, the area of these two squares together, you get the same area you have as in the red one. And watch these videos if you're at home, and you can kind of see this illustrated in a nice way. Another way to put it, A squared plus B squared equals C squared for every right triangle. Okay, so finding side lengths of a right triangle. What you do is you label the sides A, B, and C. Substitute the known values into the Pythagorean theorem. So we'll give you some numbers for two of these three sides, and then you're going to solve for the missing variable. So here's what we're talking about. You've got these two numbers. It looks like we've got A and B, and we're going to be looking for C. So remember, the Pythagorean theorem says A squared plus B squared equals C squared. Or you could just reverse the way that they're written and have C squared on the left side. Well, 12 squared is 144, and 5 squared is 25. And so if I add those two together, I get a 169. And all of that's going to equal c squared. So now if I do a square root of both sides so that I can find c by itself, I soon find out that the square root of 169 is 13. So c is 13, and I just needed to know those two numbers and the Pythagorean theorem to find it. All right, how about this one? We've got a squared, which in this case a and b are both the same number, so 4 squared plus 4 squared equals c over here squared. Also 4 squared is 16, the other 4 squared is 16, and all of that equals c squared. And 16 plus 16 is 32, and that equals c squared. Now to find c, which is what we're looking for here, we just have to take the square root of both sides of this equation, and we get c equals the square root of 32, which if I do that on my calculator, like you can do that on your calculator, you just type in the square root of 32, and you end up with about 5.656. And there's some more decimal even after that. But if you round it to the nearest tenth, you get 5.7. So depending on how they ask the problem in your assignment, that's what you'll do. Okay, here's another one. So if you notice, they've kind of tipped this over so that the right angle is sticking up in the air, but these are the two sides that intersect with it. And over here they've got this letter X, which is really kind of sitting in the place of where C would go. So we're asked to find this length right here. So a squared, 40 squared, plus 9 squared equals c squared. 40 squared, that's 40 times 40. So on the calculator, 40 times 40 is 1600. 1600 plus 9 squared. I know that 9 times 9 is 81. Now that equals c squared. So 1600 plus 81 would be 1681, which equals c squared. And then to find c, you just take the square root of 1681 on your calculator. So 1681 square root. Oh wow, that turns out to be 41. So c, side c in our case, is 41. Okay, excellent. How about this next one? We've got an a squared, we got an a here, we got a b here, so we're looking for c. So a squared would be 10 squared, b squared would be 5 squared, equals c squared. To put it in the Pythagorean theorem formula, 10 squared is 100, 5 squared is 25, and all of that equals c squared. So 100 plus 25 is 125, and that equals c squared, right? So, give us a little more room here. Take the square root of c squared and 125, we end up with c on one side, and then 125 square root is 11.2 units on the other side. Okay, so there's our number. All right, what do we do on next? Okay, we'll just keep doing a couple more examples, and in each case you find out that on this assignment, we are looking for the hypotenuse. We're kind of keeping it pretty straightforward. So a 3, so a squared plus b down here at the bottom squared. Okay, so a squared plus b squared equals c squared, right? So 9 plus 36 equals c squared. And 36 plus 9 would be 39. 45 equals c squared. So now let's do the square root of both sides, and we get c equals, and 45 square root, that would be 6.7. So there you go. We're all solved on that particular problem. All right, what else could we ask? Well, that should be enough examples to get you through today's assignment, which is number 82, Introduction to Pythagorean Theorem. It's on Alex. And you'll want to use some box paper to show your work how you do a squared plus b squared equals c squared to find those missing sides. Thank you very much.